And hello everyone, welcome back to our OpenFOAM discussion. So in the last video, I've actually just finished our OpenFOAM, using pisoFoam to go and run using a semi-parallel script. And you already know what's inside the semi-parallel script. So just uploaded that into GitHub, pushed the changes up as usual, and to this thin flat flow snappyx mesh. Again, the link should be in the description. Alright, so let me pull this out. And yeah, I'll just quickly sign in. And yeah, then this is where you'll find my stuff. Thin flat flow snappyx mesh. So this is where this is where you'll find the commits, and this is the refined pisoFoam snappy pipe case. Alright, so first thing first, well, I don't think we need to visualize the changes, but okay. I mean, it's gonna be the same, it's just run in parallel. Alright, so I don't believe there'll be any differences yet. Okay. So take a look at this, and then we see, oh right, this is pretty much the same. Okay, so let's put U, and let's go to 1000, and then let's rescale. Okay, so pretty much the same as before. Our OpenFOAM situation, we have this blocky thing, but it's the main thing about parallel processing. It's not about the mesh, it's about the speed. So let's take a look. Let's take a look at the pisoFoam, and let's see how long it took to process. Okay, so look, the clock time is about 23,000 seconds. Okay, and let's take a look at the other one, CD turbulent pisoFoam snappy pipe. So this is just doing it without the parallel run, also for about 1000 seconds. Let's take a look at the log.pisoFoam, and we take a look. The time saving is about a few hours. So this parallel processing is very useful. But what's the pros and cons of it? Remember that parallel processing, we have more processors in this task manager, for example, is using more CPU and more memory. So if you have a serial process, you are just using less of the CPU power. So you can use it to do other things. But if you want it faster, but you are using more CPU power, you use this parallel processing kind of a thing. So how to optimize it? I'm not going to say too much here. How to optimize this parallel processing? Because it's still intermediate, right? The other stuff is advanced. You just want to get the case working. Alright, so this is just results comparison in terms of time, and of course we still want to make changes, right? We still want to make changes to this refined pisoFoam snappy pipe. Okay, and yeah, let's take a look at the snappyx mesh as well. This is something we're very familiar with, and this is done in 42 seconds. Now, normally, I think in a few videos back, when we saw snappyx mesh being executed in parallel, it's run in about 18 to 20 seconds. So there is a significant speed increase. All right. Of course, we ideally want to run both in parallel. Using this script. So we'll talk about that in future videos. Okay. So yeah. And the idea is to run snappyx mesh in parallel, then kind of condense everything back using a reconstruct parallel mesh, and then decompose again and run pisoFoam. Now there are a few things when running parallel that you got to take note of. I mean, I experienced some bugs when I was running this thing. Okay, so I don't know whether it's here. Okay. Yeah, it's not here. Never mind. Okay, so basically when I was running this semi-parallel case, the thing ran semi-parallel. So the thing ran pisoFoam, but I think my computer was like, switching off and going to sleep mode and stuff. So the pisoFoam stopped, or some other processors stopped, and then the reconstruct parallel script was run, and I had to basically I could not continue the simulation from then on. It was very difficult to just continue running even using the latest time control dictionary. So it's a little more challenging, I suppose, to run in parallel if you're using this script. Then there are some other considerations that you have to do, because the time steps are all in these processes, and then if you want to continue running after stopping halfway, there may be problems. So yeah, do make sure, at least for parallel, the best way is to make sure the computer is undisturbed for whatever amount of time you need. Unlike running in serial, where I think continuing simulations, if let's say it stops at 250, you can just easily continue using the run latest time in the control dictionary, right? So yeah, you can start from either 0, or you can start from the latest time. You can start from start time, which is this, or you can start from latest time. So latest time is usually what I'll go for. But of course, in parallel, it's way more challenging to run that, because there is this decompose and reconstruct, which kind of complicates matters a bit. But all in all, it's a very useful tool for us to learn. Okay, and the other thing, I think I forgot to actually present the results of pisoFoam or SimpleFoam, which was actually run a few simulations ago. So let's navigate to that folder. I'm going to fast forward this part, of course. Alright, so this is the folder I was talking about. There's a pisoFoam or propeller case. Well, so basically the snappyhex mesh, when we take a look at it, it runs in about 600 seconds or 10 minutes. This was run in serial, as we can check on top. So this is run in serial, there's no parallel modifier. And we can look at the log.pisoFoam. Again, we find that there are some errors, which is kind of strange for a tutorial file, but there are errors in it. So okay, I should just go to the top. It says, yeah, pisoFoams run in parallel. But on the whole, at least the pisoFoam is running. It's just some errors along the way. But thankfully, at least for our case, the pisoFoam was running. As it ran successfully for 1000 seconds, it gave us the appropriate results. And it kind of slashed the time by about 33%, 1/3 of the time. So all in all, this parallel thing is very useful, and we still want to see whether we can continue doing a parallelization of snappyhex mesh and pisoFoam in the same script, or at least do a script that says, I want a mesh generation in parallel, then I go and run, or something like that. Okay, so anyway, next time we'll go and investigate into that. At least we have one solid simulation, and then of course we can try and make edits to this file, right? We can make edits to this file any way we like, and then if we want to revert the changes, all we have to do is delete everything. Okay, so let's say I mess the file up so badly that I want to redo. So all you have to do is just delete it and git reset hard origin master. This is one of the most useful things I ever like to do. So it's going to check out the files and it's going to restore everything almost instantly. So let's take a look, and there it is, back again. Refine Snappy from the Snappy pipe, and ta-da! Alright, so yeah, I'm gonna put the GitHub file there for you to see. And just remember, we can mess up, as long as it's in our GitHub, we can mess up the files any way we like, and then we can just do a hard reset on everything to restore everything to normal, which is one of the great things about using Git. All right. Thanks very much. I'll see you guys next time where we can, talk about experimenting a little bit more. All right. Bye-bye.